So we continue this week with our study of derivative securities and options. And our first focus is going to be to take a deeper look at option pricing theories. So let us start out by looking at a figure that we saw previous week. So this is a figures from Yahoo Finance, and it lists a situation related to options related to stocks of Microsoft on September 10. So on September 10, 2021, the price of Microsoft one share of price of Microsoft was 295.71. And we can see that there were different options being traded. So the options, as discussed, typically specify expiration periods. So the ones that are here, for instance, have expiration period on October as well as on December 2021. They have associated with them strike prices. And we can see here the prices of the different call options as well as put options. So we can actually see several patterns that are emerging, right? So we can see that, for instance, for a given expiration date, as the strike price goes up, the price of the call seems to be decreasing, whereas the price of the put option seems to be increasing. Then again, we can fix the strike price. So let's say we fix it at 290, then we observe that the call price option for a later time period seems to be higher compared to that, right? And we can see that this is true for all the three call periods that we see here. Similarly, we can see that the put prices seems to have a higher uh, price for a given level of strike price, but for a longer expiration period. So are there any systematic explanations for why we see the changes in the prices of different options for these different features of the options? So that is what we wish to investigate now. So let's start out by noting one interesting fact, which is that you can have call options which are out of money but still have positive value, right? So what do we mean by option which is out of money? So we are thinking of a situation where the strike price is below the exercise price. So if we go back to this figure, remember that the stock price is 295.71. But we can see that the strike prices are 300 and 310. So that you have a situation where this is exactly what is going on, right? So you have the stock price below the exercise price, but we can see that these options are still selling for a positive value, right? So what does that mean? It means that even though immediate exercise of these options would be unprofitable, in the sense that if you exercise them, you're going to get a negative payoff, the call still has value, right? It still is selling for a positive price. And the reason is because you have got traders in the market thinking that there is a chance that the stock price is going to rise above the exercise price by the expiration period, right? So, for example, what this this option being selling for a positive price means that there are enough traders who believe that there is a good chance that this price, which is now 295.71, is going to, in fact, rise above 300 by the time this October 1 happens, right? So that's the underlying belief, right? So either that is going to be the case, in which case the options are going to have a positive value at that point, or you are going to have a situation where the option is going to actually expire without being used, right? So this is the idea that with some probability you have got it going to get positive value, and with some probability it's going to take a zero value, and hence in expectation you can expect that it's going to have a positive value, and hence the price is positive, right? So let's think about how to disentangle different effects. So this value S0 minus X, so remember S0 is the price of the stock currently and X is the strike price. So this difference S0 minus X is called the intrinsic value of the call option if it is in the money, right? So remember, in the money means that the stock price is more than the strike price. So this gives the payoff basically that can be obtained if you immediately exercise this, right? So if you have got that this is positive and you immediately exercise this option, this is what you are going to get value, right? And we are going to call this the intrinsic value of the call option. Now, what happens if this is either zero or negative? So if the option is either at the money or out of the money, in that case, we are going to say that the intrinsic value is equal to zero, right? Now, this intrinsic value is part of the price, but is not the whole price. So the difference between the price and the intrinsic value is called the option's time value. Okay, so what is the time value? So in this context, the time value actually refers to the difference between the option's price and the value it would have if it were expiring immediately. So it's the part of the value that can be linked to its remaining time to expiration, right? And this time value is basically what explains why you have options which are out of money at the moment but are still selling for a positive price. Now, what is the significance of this time value? Well, typically this is the value of the option that is accruing to it, because one does not know what's going to happen in the future, and so therefore one might not actually want to exercise this option, and therefore one gets a value from this right of not taking a particular action if the action is unprofitable, right? Now, we can also kind of like go further and note that as the stock price increases, clearly it becomes more likely that the call is going to be exercised by expiration. And if you have got stock prices getting even larger, when basically you are almost certain that the option is going to be exercised, then in that case, we can think that the option should actually reach the adjusted intrinsic value, which is the stock price minus the present value of the exercise price, right? So this S0 minus PVX. Why is it the case? Because if you're almost certain that the option is going to be exercised, then uh, basically you can actually think of it as a situation where basically you are purchasing a stock for X, right? And it's as if you already own the stock already. So, okay. So you have to pay the exercise price in the future. So what's the present value of that price that you have to pay in the future? So that's basically present value of X. And basically this, because you are getting to own the stock once you exercise it, the call options value will basically be S0, which is the value of the stock now, minus PVX, right? So we can represent the whole discussion graphically. So what we have here is basically the stock price, right? And what we have on the y-axis is these different things that we have plotted. So this blue diagram is something that you have seen before. This is the basically the payoff if one is exercising the option. So obviously if it is less than the stock price is less than the strike price, then the payoff is zero. But as it increases, then this is basically the difference between the stock price minus the exercise price. This red line is basically what is the value or price of the call option, and this difference between the two is the time value, right? So if we go back to the discussion, this is what we said, that a difference between the two things that you have is the time value, right? And this S0 minus X, this is basically the intrinsic value, okay, that we mentioned here. And finally, the other thing that we mentioned here is that as the stock price increases, it is going to become equal to this adjusted intrinsic value, which is basically the stock price minus the present value of the exercise price. And you can see that from the graph here as well, right? So this light red or orange, if you like, line is this S0 minus PVX, right? This is what it is representing. And so as you can see that as the stock price keeps on rising, you have got that this is becoming closer and closer to this. And so that you have got that the value of the call option is going to converge to this S0 minus PVX in the limit, right? Okay. So this is basically just an explanation for what we had in the previous draft. So when the stock price is very low, then option is not going to be worth much because there is almost no chance that this is going to be exercised. So this is what happens. You can imagine in this region where people are almost convinced that because it's so far away from X, this is not going to be exercised, and hence therefore it does not have much value. When the stock price is very high, then in that case, as we have discussed, the option value approaches the adjusted intrinsic value. So this is basically this region, right? When you have got the stock price being very high, the value is going to be S0 minus PVX because of the reason that we discussed here in the slide. And if you're thinking of the middle region, right, where you have got that the stock is approximately at the money, so we are talking about this region, right? In this case, what you have is that the option curve is going to diverge from the straight lines corresponding to the adjusted intrinsic value. So you can see here that in this middle region, this gap between this option value curve, which is this red line, and these two curves is the highest, right? And this is because you have got a lot of volatility here about whether the option is going to be exercised or not, okay? So even though exercising the option today would have a negligible or in fact can have even a negative payoff, the volatility of value of the option. So because there is an uncertainty about the value of the option at this point, that is quite high. And as a result, you have got this divergence that is happening here, right? So that the time value is kind of like maximum in this region, which is very close to the boundary between out of money and in the money. And finally, the call value always increases in value with the stock price. That is true. We'll see later on reason why that is the case. But the slope is greatest when you have got the option is deep in the money. This is because at that point, the option price is going to increase one by one for the stock price. So basically what this is saying is that if the further away you are here, you can see that the slope is kind of like becoming almost parallel to this S0 minus X, right? So that the slope is actually very high here. Okay, so that is the kind of like some general observations that you can make, but we can actually also start systematically thinking about what are the variables that should affect the value of a call option. So just on top of your head, you can think of that these would be some of the factors that would be having an influence on the value of a call option. So what's the value of the stock price on which the call option is written? How much is the exercise price? How volatile is the stock price on which the option is written, how much time is left to expiration, and what's the interest rate that's currently prevailing, right? So how do these factors affect the call option? So let's go through them systematically one by one. So the first observation is that you can expect that the value of the call option should increase with the stock price and decrease with the exercise price, right? Why is that the case? Because remember, that the payoff to a call, if exercised, equals ST minus X, right? So higher the stock price, that would correspond to higher the amount of payoff that you can get from exercising that option, and hence, therefore, the value of the option should go up with the stock price. Similarly, higher the exercise price, lower the value that you are going to get by exercising the option, and so therefore, a higher value of the exercise price corresponds to a lower value of the call option. Then the third factor was the volatility of the stock price. And here we can actually say that the call option value should actually increase with the volatility of the stock price. To see this, let's consider an example. Suppose that you have a call option with an exercise price of 30. And let's consider two different scenarios. One in which the stock price is highly volatile. So it can take values 10, 20, 30, 40, 50 with equal probabilities. So now if you kind of like do the calculation, you can show that the average value is going to be 30, right? If these five are equally likely. And let's consider another situation where the average value remains the same, but the volatility goes down. So this is the low volatility scenario when the stock price can take values 20, 25, 30, 35, 40, each with equal probabilities, right? So again, if you do the calculation, you can see that the average value is going to be 30, same as the high volatility scenario, but you can see that the range of the prices that it can take is actually high, right? So it can go as high up as 50 in the high volatility region, or go down as low as 10, right? Whereas in the low volatility region, the highest value is 40 and the lowest value is 20, right? So the spread is much lower. Now, if you actually calculate the value of the option for each of these scenarios, so if you have got, for example, in the high volatility scenario, in 10, 20, 30, the value of a call option with exercise price of 30, the payoff is going to be zero, right? If the price of the stock is 10 and the exercise price is 30, you are not going to exercise this option. And so therefore the payoff is zero. Same for 20. And in 30, you are indifferent between exercising and not exercising, because even if you exercise, you get zero, right? So in these three cases, you get zero each. If the price becomes 40 and you exercise it, you end up getting a payoff of 10. And if the price is 50 and you exercise it, you end up getting a payoff of 20. So what that tells you is that you are going to get 10 with probability 0.2, 20 with probability 0.2, and 0 with probability 0.6. And now if you do the calculation for the expected payoff of the call option, that is going to be 6, right? So it's 0.2 into 20, which is 4, plus 0.2 into 10, which is 2, plus 0.6 into 0, right? So from there, you get this number 6. What happens in the low volatility scenario? So again, for 20, 25, and 30, the payoff from the call option is going to be 0 if it is exercised optimally. And if it is 35 and 40, then there's going to be a positive payoff. So a payoff of 5 when the stock price is 35 and the call option is exercised, and a payoff of 10, right, when it is exercised. So again, if you do the expected payoff, so it's zero point 0.2 into 10 plus zero point 0.2 into 5, right? So 0 0.2 into 10, remember, is 2, 0 0.2 into 5 is 1, and again 0.6 into 0. So you end up getting that the expected payoff is 3. So if you now compare these two scenarios, you can see that in high volatility scenario, the expected payoff is strictly higher, and hence the call option has a strictly higher, actually, price when the volatility is higher. Okay, so that's the third factor. What about the remaining factors, time to expiration and interest rate? So here, let's think about the reasoning. So if you have a longer time to expiration, that increases the value of call option. And there are actually two reasons why that is the case. First, if you have got more time till the this option expires, then there are more chances for unpredictable events to affect the stock prices, and the range of possible stock values increases, so that you end up with a high volatility scenario compared to if you have got a smaller time remaining for the exercise period to be over, right? So this first explanation says that if you have a higher, longer time to expiration, then that increases the volatility and therefore will increase the value of the call option. The second reason why the value of the call option will go up with time to expiration is that, remember, if the thing is exercised, you have to pay the exercise price. And so from today's perspective, the amount of money that you have to pay is equal to the present value of the exercise price. Now, if you have got a higher time horizon till you actually pay the this exercise price, so therefore the present value of the exercise price is going to fall, and so therefore again the value of the call option is going to go up, right? So both of these factors are causing the value of the call option to go up. All right. Finally, the remaining factor was interest rate, and this is actually linked to the present value of the exercise price again. So call option values are higher when interest rates are higher, holding, of course, the stock price constant. And the reason is higher interest rates, again, reduce the present value of the exercise price, and hence, therefore, they increase the value of the call option, right? Because again, the exercise price is something that you are actually paying, right, once you exercise the option. Okay, so you can actually go ahead and do a similar reasoning for the put values, and you can argue that the put values should also depend on all of these six factors, and the reasoning actually maps almost similarly, right? So, for example, here we argued that call value should increase with the stock price and decrease with the strike price. In the put value case, the reasoning is exactly the opposite, right? Because once you exercise it, you end up getting X minus ST. And so therefore, the put values will increase with the lower stock price and increase with the higher exercise price, right? And you can actually go back and see here that as the strike price is going up, the put price is actually also going up, right? Which makes sense, right? Based on the exactly the same reasoning that we discussed before. Now, the other interesting thing is that as you have got increase in volatility, we had seen that the call price the call options price should go up. And actually, because of the same reason, the put options price should also go up, right? And in fact, I encourage you to do the same analysis here as before. So remember, the put option is going to be exercised when the stock price falls below the strike price. So suppose that you had a put option with the exercise price of 30, then in this high volatility scenario, you're not going to exercise it when the price is 40 or 50, and you're indifferent between exercising it or not when the price is 30. So you'll exercise it only if you have got the price falling to 10 and 20, each of which happens with 0.2 probability. And again, you can do the same calculation, and the expected payoff of the put option in the high volatility scenario is also going to be 6, right? And if you do the same calculation for the put option for a low volatility scenario, you can show that the expected payoff from the put option is going to be 3 as well, right? So exactly same argument tells you that higher volatility is going to lead to a higher expected payoff for the put option, and therefore a higher price of the put option as well, right? So put value increases with the volatility of the stock price. Okay. So the reason intuitively is again kind of like simple. So you have typically got one side, both for the call option and the put option, where in one side it is not worth exercising the option, right? And in the other side, once you exercise the option, the further off you are away from the exercise price, the better off you are, right? So in the call price scenario, call option scenario, the further higher the stock price is compared to the exercise price, you are better off. For the put, it's the opposite scenario. But in each case, you want to be as far away from the exercise price so that you end up getting more and more money, right? Whereas if you are far away in the other direction, then it doesn't make any difference because you're going to be getting zero, regardless of whether you are very close to the exercise price and below the exercise price in the case of call option, or if you are very far away from the exercise price and uh, you are below that, right? So it doesn't matter whether for a call option you are 10-20 compared to 30 or 20-25 compared to 30. In each of these scenarios, you get zero. But it does matter how far away you are in the opposite direction, right? So 50 compared to 30 leads to a payoff of 20, whereas 40 compared to 30 only leads to a payoff of 10, right? So these extreme values are better for you if you actually own the option, and hence, therefore, the price of the option goes up whenever you have got a increase in volatility. Okay, what about the interest price? Well, this is going to have a negative effect in the sense that a lower interest rate is actually going to increase the value of stock, and this is actually opposite compared to what we had before, right? Where remember the call option value was higher when the interest rate was higher. But the reasoning is actually simple, right? So remember, when you exercise the put option, you end up getting, if you do exercise it, you end up getting X minus ST, right? So from your perspective, from today's perspective, you're getting the present value of the strike price, and therefore a lower interest rate would correspond to a higher present value, and therefore that would correspond to a higher price of the put option. Interestingly, time to expiration has indeterminate effect in the sense that it can actually lead to an increase or a decrease in the put value. And the reason is because similarly to what we had discussed. So remember, the longer time to expiration increased the value of call option because of two reasons, right? One is that it led to higher volatility, which leads to an increase in price of the call option, but it also led to basically a reduction of the present value of the exercise price, which led to a higher value of the call option. Now, when we are thinking in terms of the put option, the first reason also would suggest that if you have got more volatility, that should lead to a higher value of the put price. So this is still working in the favor of the put price. But in the second case, if the present value of the exercise price falls, we know that that's going to have a negative effect on the value of the put option, right? So we don't know which effect dominates, and hence we cannot say just intuitively what's going to be the effect of a higher time to expiration when it comes to thinking about put prices. That is one difference compared to the reasoning that we gave with the call options, right? So same mechanisms taking place, but in the case of call options, these two mechanisms were reinforcing each other. But in case of a put option, these are actually acting in the opposite direction. Okay, so we are going to see actually a few quantitative theories where we try to put numbers on what should be the price of these things, right? So far, we have been discussing intuitively, but all of those actually, you will see that rely on some implicit assumptions, right? And depending on different assumptions that you get, you are going to come up with different numbers, right? So before we get into specific models, we might try to think about, generally speaking, what are some properties that we would expect that all of these models would give us when it comes to thinking about what should be the price of, let's say, these call options, right? So let's first think about, without settling down into a particular model, what should be some general properties that should hold regardless of whichever model we are talking about. So for instance, how high or low can a call premium be? So one can use some of the type of arguments that we have seen before. So no arbitrage arguments, or the principle of replication that we saw last week, to think about what should be some bounds that can be placed on this call premium, right? So remember, C is the amount that one can purchase or one can sell these call options for. So what are some restrictions that we can place on this C? So the first restriction, which is also kind of obvious, is that C cannot be something which is negative, right? So C has to be something which is greater than or equal to zero, right? Why is that the case? Well, Because remember, the payoff from owning a call option is at worst zero, right? So if it is the case that the stock price is too low, so you do not get to exercise the option, and hence you end up getting zero, right? But you do end up with some probability also exercising the stock price, right? In which case the payoff is positive. So you have got that in some cases payoff is zero, in other cases payoff is positive, and so as a result, in expectation, you would expect that the option is going to have some positive value, and hence the call premium is also going to be some number which cannot be negative. So that's the first restriction. All right. The second restriction is that the call premium, this amount number C, has to be something which is less than equal to S0, right? So S0, remember, is the current price of the stock. Why is this the case? Well, in order to see this, let's compare what's the payoff from owning a call option versus what's the payoff when it comes to owning a stock, right? And we are looking at the stock price at the time of expiration, right? So there are two possibilities. Either it is going to be less than equal to the expiration of the strike price, or it's more than the strike price, right? So in each case, the value of the stock is going to be ST, right? What's the value of the call payoff? So if the stock price at the time of expiration is less than equal to the strike price, then the call payoff is going to be zero, right? So we can see that the price of the value of the stock is going to be more than the call payoff in this case, right? What happens if ST is more than X? Well, in that case, the payoff of the call option is one exercises this call option and gets a payoff of ST minus X. Again, we can see that this is something below ST. So we can see that regardless of the state of the world, the payoff from the call is actually going to be below the stock price. And hence, the price of the call option has to be less than the price of the stock. And the price of the stock today is S0. So therefore, C has to be less than S0. Right. So that's the second thing. Now, that is an upper bound on the value of C. So far we have stated an upper bound as well as a lower bound, right? So we have stated that C is greater than equal to 0. We have stated that C is less than equal to S0. But can we improve our bounds? Can we come up with another lower bound which is better than 0? So in order to do this, we are going to rely on the principle of replication. So let's consider two strategies. So you have got here a call option, right? Which is what we have been talking about. So suppose that you are talking about a call option on one share of the stock, which has a strike price X and a time to expiration of capital T. Okay. And the other strategy that we are going to consider is what is known as leveraged equity. So what does that mean? That means that you are borrowing some amount of money. In particular, you are borrowing X plus 1 plus RF to the power T. So remember, T is the time to expiration and RF is the risk-free rate, and you're buying a share at S0. Okay, so we want to look at what happens as a result of doing this strategy. Now, if you actually write down in a table, again, the same thing that we have done before. So depending on the different values of the stock price at the expiration time, we are going to have different things, right? So the first entry should look very familiar. It's in fact exactly the same that we had before, right? So if ST is less than equal to X, you are not going to exercise the call option and hence your payoff is zero. And if ST is more than X, your payoff is going to be ST minus X. Now, what happens in case of the second strategy, this leveraged equity payoff? Remember that you have borrowed this amount, right? So therefore, you have to return this amount now. How much do you have to return? Well, this is the amount that you have borrowed, and you have to pay interest rate for these 2 periods. So you end up returning X, right? And this is something that you are returning regardless of the state of the world. You also have purchased the share, and what is going to be the value of the share? Well, that's going to be ST, right? Now, we can actually compare the payoffs that one gets from the call option and one gets from this leveraged equity payoff, right? So we can see that whenever you've got ST strictly greater than X, these two payoffs are going to be the same. Whenever you've got ST is less than equal to X, we can see that the call payoff is zero, whereas the leveraged equity payoff is ST minus X. Now, with ST is less than equal to X, ST minus X is actually less than equal to zero. So if we compare now the two different states, we can see that the payoff from the call option, call payoff, is always at least as high as the payoff from this leveraged equity payoff, right? So what that means is that because the first strategy, which is buying this call option, is giving you always a weakly higher payoff, in the sense that it's giving you the same payoff or at strictly higher payoff if you consider different states of the world compared to the second strategy. So therefore, the price of creating the portfolio in the first case which is of getting this call option, has to be more than the price of the second strategy, right? So what's the price of the first strategy? Well, that's just, you have to purchase this call option. And so therefore you get that the cost of this call option is C. What's the cost of the second strategy? Remember, you are doing two things. You are buying a share at S0. So this is one cost, right? S0. And you are borrowing this amount, right? So borrowing means that this is actually entering into your cost negatively. So you've got that S0 minus X by 1 plus RFT, right? So what we got from here, that the price of the call has to be weekly higher than the cost of the second portfolio, is that you end up getting this bound, right? That C has to be greater than equal to S0 minus X by 1 plus RFT, right? Now, if you recognize the second term, this is nothing but the present value of X, right? So another inequality that you get from here is that because X has to be always basically the present value has to be less than the X, right? So from there you end up getting that C is at least greater than equal to S0 minus X, right? So we can see that these type of arguments, arbitrage, no arbitrage basically, as well as this principle of replications, they are often helpful in coming up with these bounds that we discussed. Now, more details need to kind of like rely on specific theories, and that is what we turn our attention to next.